Hello and welcome to today's webinar. This is Mark Plantier of Enercon Industries, and we'd like to thank you for attending today's webinar, an application engineer's guide for using plasma treatment to improve adhesion. Please note that this webinar is being recorded, and you will receive an email with access to both the recording and the presentation slides within 24 hours. If you have any questions during the webinar, please use the GoToWebinar question tool. We will reserve time at the end of the webinar to answer as many questions as we can. Our panel today includes surface treating experts Sarah Bauer and Ryan Schilke. Sarah is an Enercon surface treating application specialist and every day works with our customers to determine which plasma or flame technology will work best for their applications. Sarah has shared her insights at numerous industry events and webinars. Ryan has been with Enercon for over 20 years and as VP of Sales leads a team of passionate surface treating specialists in developing and implementing solutions that enable adhesion success across all types of applications and industries. Today's presentation will cover why surface preparation is needed, why plasma is replacing existing surface preparation techniques, how plasma works and how it cleans, etches, and functionalizes surfaces, how you can measure the effects of plasma treatment, and we'll cover numerous industry examples and applications including printing, bonding, decorating, and potting. With that, I will pass it over to Sarah Bauer, who will begin the presentation talking about adhesion.
Good morning. Thank you all for attending. I appreciate you taking the time out of your day to be here. I'm excited to actually talk to all of you about surface preparation in general. That's kind of where we're going to start. Talk about plasma, of course, being our main topic, but also some of the other alternative technologies available. Hopefully striking a chord with some of you that do work in surface preparation or want to just learn more about the different technologies available. So I'm going to start by talking a little bit about cohesion and adhesion. And talking about, in general, when we're talking about trying to get something to adhere better to the surface, you've got two different pieces to look at. When you're looking at the forces of cohesion, this is when you are actually trying to get the molecules that are sitting on the top of the surface. What we're trying to do with the use of a surface preparation technique is to create a better bond of adhesion, and that's where we're actually creating a molecular bond between the liquid. Keep in mind that liquid could be an adhesive, it could be a coating, it could be a paint, and the surface of the actual material you're working with, whether it be a plastic, metal, or other organic material. I'm going to start to talk a little bit about the options available to you when you are actually trying to prep a surface for better adhesion. So in order to talk a little bit about interfacial compatibility of surface and coating. So there are a couple options when you are working with, let's just say a coating, for example, here. You would like to possibly get a better adhesion here, but you're looking at maybe modifying the coating itself. So one of the options you could look at is a more aggressive coating, so maybe a solvent-based coating, something that's got more chemicals in it. One of the downsides to that, and this could be with adhesives or inks as well, is that you've got an additional cost. Typically, there's more consumables involved. You've got cleanup, and it's a very hazardous, way of doing things. Yes, it works in the end to use a solvent-based coating, but it's just not typically the preferred method of getting good adhesion, especially if you are looking to become more of a green company. Or if you are looking at possibly getting away from the use of chemicals as well. So what are your options? Can't change your coating or don't want to, what can we look at? There's basically breaks down to 5 different categories when we talk about surface preparation. One would be a primer, so this could be something that works in conjunction with your coating or your adhesive. It might be chemically matched to that from the supplier itself, or be something that you use on the side. The downside is it is a consumable, When we're working with primers, one of the biggest complaints that customers get is human error. You've got someone manually wiping a surface and they look away for a second and go back and look at the part and go, oh no, did I actually wipe that? I can't remember, and then moving on. And so now all of a sudden you've got a lot of opportunity for something to not get properly prepped. Another option is a chemical etch. We see this a lot with working with Teflon or any kind of fluoropolymers that are very, very low surface energy. Don't allow customers to bond to it very easily because everything is very hydrophobic. What we do find is that this process is very expensive. There are quite a few companies out there that do this. It's very effective, actually, at treating a surface. But now you've got an additional expense of taking your product, sending it off to get chemically etched. But it's a permanent etch. So that is one of the benefits that doing a chemical etch allows you. Maybe you need to prep 100 pieces and put them in a storage facility. This is a really good fit for it. Another option would be a mechanical preparation. So this would include such things as sandblasting or maybe physically roughening the surface with sandpaper, or any other kind of means to actually physically create a more roughened surface. There's a time factor that goes into this, so now you've got another step in your process. You've got wear parts if it is a physical roughening with like skiving or actually some sort of a Dremel wheel or something like that. And really it all comes down to cleanup. A lot of people who choose this method, it tends to be very messy, especially if you're using sandblasting. This has to be done in its own cell, and it can be time consuming and costly that way. But at the end of the day, if you are working with something, this is a really good solution for a majority of the customers out there that just need to quickly etch a surface and get it a better bond adhesion between their ink coating or adhesive. Another option you could look at, and some of you may or may not be familiar with, is a vacuum plasma. A vacuum plasma, for those of you who are not familiar with this technology, is where you actually have a chamber of some kind where you would put a part inside. You would pump down a gas chemistry and it would treat the part 360 degrees wherever it's exposed to the plasma. The downside to this, however, is that the initial capital investment is pretty high. The equipment itself is not inexpensive by any means, and you do have a consumable cost such as a gas such as argon or something like that. And it's also a batch process. So this works great if you're in a small volume lab environment, but maybe looking to move to more of an inline process. So that could kind of come and tie into the time factor. But it's very effective at treating quite a few different types of materials if you have the time and the means to initially invest in the equipment. And then the fifth category comes down to atmospheric flame and plasma. We're going to focus a little bit on that today, but I'd like to kind of point out some of the pros and cons as well. So atmospheric plasma, as opposed to vacuum plasma, is where you're using a head design that's going to be treating in line, so over a conveyor, on a robot. It's a continual process. There is an initial investment as well in this versus something such as just using a piece of sandpaper on a part. So you do have a capital cost there, and it's going to be a little bit more limited to, if you have a very complex shape, you're going to have to manipulate the head in some way over, let's say, a vacuum plasma. So there are some pros and cons with that particular technology and route as well. So one of the questions that we always ask customers when they first come to us, or even you might be asking of yourself right now, is, how do I know which of those 5 options are best for me? So one of the questions we ask is, do you need something permanent? Are you going to be etching a surface or prepping a surface that needs to hold that etch for a long period of time, or is it just temporary? Are you planning on applying the coating adhesive or paint in line with the surface preparation technique? Who's controlling it? Do you want to control it? Is your supplier controlling the surface treatment or the surface preparation? Once again, batch and in line, do you have all the time in the world, or is this a very, very quick process? And then also, what are you looking for as far as an initial investment? A piece of sandpaper is very inexpensive. A bottle primer may not be much of an investment. A piece of capital equipment might be obviously much higher. Do you have the capital to invest in this right away, or is this something that you need to ramp up towards? And all of that being said, once you have an opportunity to kind of evaluate what your needs are, then it's good to take the next step. And if that next step happens to be atmospheric plasma, that's where we can come into play and help you. I'm going to turn the mic over to my colleague Ryan Schulke now. He's going to talk a little bit more about what is atmospheric plasma, how it might be a good fit for what you do, and if you're even considering it, it might give you a couple more pros and cons as to what it can offer you.
Thanks, Sarah. So one of the questions we get every day, Sarah's safe to say we probably get this every day, and ask, what is a plasma? That specifically, and very simply speaking, a plasma is an ionized gas. You can look at this in a variety of different applications. You've probably seen it different ways in everyday life, but when we're talking about atmospheric plasma for treating, what we're really doing is we're ionizing a specific gas. For most atmospheric plasma applications, what we're ionizing is simply air, and that air is usually, the source of that is typically a compressed air, but we may also use a technology like flame technology where what we're ionizing or burning off there is natural gas or a propane flame. You can additionally add a process gas depending on the application. In fact, as we were sitting here prepping today, Sarah and I were just talking about an application where that was specifically the case. They weren't able to achieve the levels that they were looking to achieve just using standard air for their ionization method. So when you plasma treat a surface, what specifically happens? So there are three things, and we're going to look at this two different ways. And the first way we're going to look at is, let's talk about what's going on the surface. So the first thing that we're going to do is we're going to remove low molecular weight components from the surface, and we oxidize that remaining surface. So that's one of the things that we do. Secondly, we're going to cross-link the molecules on the surface of the part in which you're treating. And in addition, we're going to increase the number of polar groups, which in turn ultimately leads to enhanced adhesion on whatever surface that you're talking about. You can look at this another way, and we often look at it a couple of different ways, in that we're also then talking about three things that we do. And oftentimes this one simplifies it for most folks in saying that we clean, etch, and functionalize the surface that we're dealing with. So when we talk about cleaning, we're removing both organic and inorganic compounds from the surface. This can be usually a light cleaning if a part is caked in dirt, caked in dust. There are limits to which you can clean, but oftentimes it will clean a lot of surface contaminants from the surface. We're also going to etch the surface, and this, as Sarah talked about mechanical methods, when we talk about roughening, whether it's with sandpaper, sandblasting, another process, what you're really doing is you're adding more dimension to the object in which you're trying to increase adhesion. What we do with plasma treatment is we're actually micro-etching. That's really a more exact term for what we're doing, and we create more bonding sites to adhere to. Finally, we're going to functionalize the surface, and in that what we're really doing is we're increasing the polar groups that are present on the surface, and we'll talk a little bit more about that here in the next couple of slides. So anytime you look at a plasma treating process, or really any process to determine are you being effective with whatever your process to activate that surface is, we're going to look at, you've got to look at some process. With plasma treating, one of the most common processes that are used is measuring the dyne level of a surface. And this is really a simple, inexpensive test which can be done as you're going through and either setting up your line in a lab, whatever it might be. You're going to use a particular solution and wipe that solution across the object, and really with your naked eye look to see does that wet out or does that lay down flat on a surface. And you do this across various levels, and that will tell you, you'll begin to see where you have good treatment, where you don't. You're typically going to look at the product with a dyne level before you treat the product and then after as well. You can get a little more advanced by measuring the contact angle, and you can look at the contact angle in a couple of different ways. The image that we've got on the upper right is a device which is actually going to measure that electronically. using a couple of different droplets, and we're going to be able to get not only the contact angle, but we're going to be able to measure the polar and non-polar groups on the surface as well. You can look at the peel strength. So you can look at if you're bonding two components together, what does it take to peel those two components apart? And in many cases, when we're talking about printing, painting, sometimes coating, you can actually look at a tape test as well to look to see, does your final process, is that removed after it's been treated and then that printing, painting, or coating has been put on it. At the end of the day, you've ultimately got to choose which one or combination of these methods is best for your application. So let's talk about dyeing levels a little bit more. What you're going to see on this screen is we're actually going to look at some common materials that we see in our lab and that we see out in the field, and some initial dyeing levels. Generally what you're going to see is many plastic materials start out with dyeing levels somewhere in the low to mid 30s. It's pretty consistent across these different materials. When you use treatment methods, and what you'll see is that you can range anywhere from the 40s up to the 50s, or even up to water wet levels up at 72. So there are some areas there where you get different levels of treatment based on the materials, also based on the technologies that we'll talk a little bit more about coming up in the presentation here. What's important to know is what you're really aiming to do is you want to raise the dyeing level of the surface 10 dynes higher than that of what you're trying to put on it. So if you're using an adhesive, there's going to be a dyeing level or a surface energy level related to that adhesive, which you will know you'll be able to get from your manufacturer, and we want to go out and exceed that level. Dyeing level is a great measurement. Again, it's easy to use. It is quick to use. It's pretty inexpensive, but it's not always the most accurate predictor. We'll have applications that come in where we see a significant dyeing level change but aren't seeing good results, and then we know that we've got to go and look at something deeper. Same thing, we have applications where the dyeing level doesn't move, but we get great success in bonding to it. So again, it's a good rule of thumb, it's a good indication, but it's not always the exact answer. So this is where we're going to start to get into polarity as well. We're going to look at the polar and non-polar components of that surface energy measurement as well. And here we'll see that one of the things that we're doing is we're generally increasing both the polar and non-polar, but generally you see in these slides that we're increasing the polar components usually fairly significantly after treatment. What we measured here specifically on these components are final surface energy with both blown ion and flame plasma technology. And you'll see that you generally get increases in both, but some materials react more positively to one treatment technology than another. And this is a pretty unique thing from Enercon's perspective, is we don't tie ourselves to one treatment technology. We actually offer 4 different technologies you can use for plasma treatment. And that really gives you the best chance, in our lab, the best chance to evaluate what technology is right for your application and really not hone in on one technology which may not be the best for you. We talked about peel strength as well. Here's another set of examples that we've done when we've measured peel strength, and you see again, typically what you're going to see is an increase in peel strength across materials. Sometimes you get better reaction with one material than another, but generally your rule of thumb is that you're going to see peel strength increase fairly significantly after plasma treatment. We see a wide array of materials come into our lab and in our customers' facilities. Very often we find great success in working with applications that include glass. Plastic, by and large, is a home run for plasma treating technologies. Metals can be a very successful application in some cases. And really, we tell folks, bring us everything. Bring us everything that you're looking at. If it doesn't fit into these categories, this is an area where we have full-time staff employed in our lab. We offer free sample testing to any prospective customer who wants to try it out and see if it might be right for their application. We can do these tests either on our own, evaluating material here, or you're always more than welcome to come in, observe those trials, and doing any additional testing you might think you need as you go on and learn a bit more about the process.
And I'll also add here too, Ryan, if you are considering maybe one of those alternative technologies in conjunction with atmospheric plasma, it's very, very common for customers to try them at the same time, to basically set up a DOE, what's the difference between sandblasting and atmospheric plasma, or a primer and atmospheric plasma. So we definitely encourage you, if you're thinking about looking at it, to do both at the same time. Sometimes you can find the results are similar, and then you get to decide as the customer which route you want to go, and sometimes one will be the clear winner.
So who uses surface treating? What applications tend to work well? Really, the applications and the industries that we play in are endless. It's everything from medical to wire and cable, automotive and aerospace. It can be folding cartons. The window and door industry uses it, construction. The applications, because of the versatility of the technologies that we're using, really we find success in increasing bond strength, increasing adhesion with anything that our customers bring to us. So I'm going to turn the reins back over to Sarah. We've got a number of applications that we're going to dive a bit more into here, which should give you some ideas on maybe things that you're working on and how you might be able to use plasma to fit your applications.
Great. Thanks, Ryan. So I'm going to give you kind of an overlay of a few different customer projects. By no means is this going to be inclusive of everything we can do, but just to kind of, like Ryan said, give you a couple ideas. If you do have any questions specific as we are talking about these applications, you want to type it into the question area through the webinar, please do. We can dive into that at the end, or we can talk with you offline if you'd prefer as well. So first I'm going to talk about two different printing applications with customers that have been able to use atmospheric plasma to increase print adhesion. The first is with a customer called Wago. They work with a nylon 66 part. We do a lot of glass-filled nylon as well. We find that they typically have very low surface energy. And so this particular customer, on the right-hand side of your screen, you can see before we introduced plasma on the bottom right hand, you can see that with a tape test, after the ink was applied and the tape was applied over the ink, it easily came off. And at the top of the screen is with plasma. The idea behind it is that this customer could produce this part, print on it with a digital inkjet, and not have any problem with it coming off, and also getting rid of that manual priming using a chemical, and no longer having the element of human error in the mix. So they were pretty successful. We were successful in helping them as well. Another printing application that I'd like to point out, it's a huge part of what we do, is digitally printing on wire and cable extruded jackets. This particular customer, Nexans, is a very large player in the wire and cable market, and what we were able to do here, if you can see on the right-hand side of your screen, there's a photo of a plasma head immediately before a digital inkjet head. And why they need plasma is because more and more companies are going to dynamic date coding and variable data coding on wire. They want to be able to change that out frequently and need to get away from contact wheel printing and other kinds of physical printing on the surface. The downside is a lot of these inks don't adhere as well to the jacket, and those jackets do come through, for those of you who are familiar with wire and cable manufacturing, they come through a water bath that can sometimes be contaminated. So by using plasma, this customer was able to get better adhesion of that ink, and that it was able to handle being installed even in the field and not rubbing off in the installer's hand or whoever's working with the wire on the back end. I'm going to talk about bonding as well. So we talked a little bit about ink, but I'll go to adhesives. Another option or application would be using plasma on a glue flat prior to putting adhesive down, with the idea that we're going to get a better bite, a better bond into that coating on the outside of a folding carton. For those of you who aren't familiar with folding cartons, this could be everything from a toothpaste box to a cereal box to a food product or anything you really find in the store. Obviously, if that glue flap comes undone, that can be a huge problem for the customer. So some of our customers choose to use plasma also as an insurance policy to ensure that that glue flap doesn't come undone. But the idea is that the plasma is going to be used right in line with the adhesive being laid down on the surface that allow them to keep their production speeds up, perhaps get away from hot melt, which can be very expensive, and go to a cold adhesive, and therefore saving time and money in doing so. Another bonding application I'd like to point out, and Ryan mentioned this earlier, we do work with a lot of automotive customers, was with Eisman Automotive. There's actually, if you want to play around on our website at enerconind.com, we have a lot of YouTube videos links there, and there's a couple photos of these treaters running and actually treating the part in action. What they're doing here is they're treating various automotive components. We've got polypropylene, ABS, different types of glass-filled plastics. If you sit in your car and look around, there's a lot of plastic components that go into automotive. But in order to get something to adhere well to it and it be able to handle the different types of hot and cold temperatures and be able to handle the vibration and all the other things that go in to automotive manufacturing, you need to make sure that bond stays not only adhered but permanent. It's really a great alternative to priming. Priming is used a lot in automotive, but as we are all trying to get leaner in our manufacturing and more efficient, using atmospheric surface treatment allows customers to do that. You'll see that these heads are actually on a robot, and if you're curious of what kind of plasma is being used here, this is our flame plasma that they're using because of the complex shape and size of the parts. Another bonding application, and this is kind of a fun one to point out for those of you who may not know, your headlamp on your car, if you've ever seen moisture inside of it, typically older cars, you'll see that where a little bit of water and moisture gets inside the headlamp. The reason why that happens is it's because the bond, the sealant to the actual lens itself is actually coming undone. So in recent years, Enercon's really been a key partner with a lot of headlamp assembly companies, specifically Hella, has been able to partner with us and actually use plasma to treat that glue path prior to putting the adhesive down, and therefore not allowing that bond to bite into the plastic more, become stronger and more permanent, and be able to withstand high temperatures. High and low, I should say that, since we're sitting here in Wisconsin today. A couple other things that I want to point out is some assembly applications. We do work in the window and door manufacturing environment, and a lot of these customers need to either wrap perhaps a vinyl around an extruded door to that wood-like look, or a paint around it, or perhaps they even need to pot or lay down a sealant glue path in order to get better bond between the glass and the actual frame of a window or door. One of the solutions to this is to use a flame treater that's pictured at the bottom right hand of your screen in order to get into a lot of complex areas and shapes. This has really been a revolutionary technology for the assembly for the window and door construction, because it allows them to get completely away from primers. As you know, a window or door needs to be able to, the bond needs to be permanent, not just for the few years you, let's say, own a car, but perhaps the 20 or 30-year warranty that the customer has promised. So by increasing their bond strength, they've been able to fulfill that promise to the customer, and also get rid of the human element and the chemical element as well in their actual manufacturing. Another goes right alongside the door, but this could also apply to other types of plastics where foam is applied, where we need to treat as a filler. As you know, many doors aren't just made of wood anymore. There's typically some sort of an insulation between the door panels, and another reason why someone would want to use flame or plasma in general is to get a better bond strength of foam to that plastic. It could also be a composite material. So instead of this being just a straight adhesive, foam is also another application that we work with on a regular basis. This could be in any case where we need to use foam for an insulation. So it's not just related to windows and doors. It could be for consumer goods or refrigeration or things like that as well. But really working with a lot of different plastics and allowing customers to keep their process moving is really the key to their success. And then the last application I want to point out that we do get involved with is potting, a lot in electronics. And the potting applications, a lot of times, are very tricky. We have different electrical components and plastic components, and one of the main questions that my customers ask is, am I going to damage anything by using plasma? Or maybe I don't have a way to get a primer in there and I'm really kind of stuck right now. What can I do? One of the really neat things is there's two technologies that Enercon offers that don't interact negatively with any metal or conductive or electrical components, both a blown ion and a flame plasma pictured here. It allows you to get into some very tight crevices, pre-treat, clean, and micro-etch, like Ryan went through earlier in the presentation, and allow you to put that epoxy or that potting compound into a cavity. Whether it be a very small electrical component or a large one, both of them have the ability to do that. And that really opens up a lot more opportunity because going back to that original list of options, typically sandblasting isn't an option, priming is not an option, so you really are going to be more limited when working with electrical components in potting. So plasma is definitely something you can look into if this is something that you work with. And then one last little tidbit here I want to just point out before we're done with the presentation and get into some of your questions is a new technology that Enercon has developed. We are calling this particular technology is called our Glow Plasma series. You can see it looks a lot different than the head designs that we've been presenting here in this when talking about atmospheric plasma. The really neat thing about a Glow Plasma series is it has the ability to treat inside of an area. You'll see that everything else that has been presented has been line of sight, and traditionally it's been very difficult to get inside of a cavity. There's an example of a cup, a preform, other customer parts and components, but in general, if you needed to treat inside of a cavity, perhaps for coating, or you are actually going to be potting in there, and in the traditional atmospheric plasma system is not going to be able to reach it, this particular technology would be a really good fit as well. And I'm not going to lie, the pictures are pretty cool looking too. So if this is something that you maybe have an application that you would like to try this technology out, please feel free to reach out to Ryan or myself or Enercon, and we'd be happy to run some trials with you as well. We're very excited about this technology. It's something that's going to allow customers to treat in line, keep their process moving, and maybe get to those areas that weren't traditionally able to reach with those other surface treatment methods. Just going to recap a little bit here. As I'm recapping, if you do have any questions, please put them in the question area on the webinar. We will try to get to as many as possible. If we can't get to them, we'll get to later, we promise. So just to recap, basically flame and plasma are both used in a wide variety of applications and industries. They're really not limited to one specific area. And if we didn't list the industry you work in here in this presentation, please let us know. We'd be happy to give you some background on where we could help. There's three things that plasma does, and I always kind of like to drive this home at the end of every presentation. Brian went through this in great detail, but it's always going to do three things: clean the surface, micro-etch the surface, and functionalize it. Those three things are always happening when you're working with plasma. There's a lot of operational benefits that plasma offers. You've got bond strength, you've got a continuous process, you're getting rid of a chemical, and you're improving your process altogether with a lot more control. You can integrate these systems, as you saw in some of those slides, on a robot, on a conveyor, and it can even be used in the lab environment. So there's a lot of different configurations available to you. And at the end of the day, we do have a full-time lab here at Enercon if you ever did want to try one of those plasma systems out. And like I mentioned earlier, in conjunction with another technology, you're welcome to do that as well. Or maybe you've kind of thrown your hands up in the air with what you're currently doing and would like to look into this a little deeper. That's where we're here to help. So please connect with us. We'd love to set up a trial and run samples in our lab or something on site as well.